Hey guys, my name is Abhay Kumar and this is AY. So on September 14, 2020, a group of scientists led by Jane Greaves of University of Cardiff published a paper about the discovery of phosphine in the clouds of Venus. Something that shouldn't have existed there but can also be connected to the existence of anaerobic life there. But what does this mean? But before what, let's talk about how. How scientists were able to discover a gas on a planet whose surface temperature reaches 424 degrees Celsius or 697 Kelvin, temperatures so high for human missions that most of the probes sent there lose their connection after a while, with now just the Japanese Akatsuki orbiting the planet. In fact, how do scientists find out about the compounds on other planets that are light years away without ever going there or sending any technology? I mean, we couldn't just find about the air on another planet just by looking at it. Turns out that's true. We found about the air composition on other planets by looking at them with telescopes. The process is somewhat like this. Just like every one of us have unique fingerprints, every molecule has a spectral fingerprint, which is unique to itself. When light reflects or passes through a molecule, the molecule absorbs and emits some frequency of this light. Splitting this light with a prism, we can see the frequencies of the light absorbed by the molecule. This is the spectral fingerprint of the molecule. This method is called spectroscopy. Observing planets and the light coming from them, we can observe the spectral fingerprints of that light and compare them to those of molecules that we know on Earth to see what molecules are present on the planet's atmosphere. This is how phosphine was detected on Venus. The study was performed by a team using the James Clerk Maxwell Telescope and the Atacama Large Millimeter Array, one at Mauna Kea Observatory, Hawaii, and the other in northern Chile. Both of these are radio telescopes, with ALMA being an array of 66 telescopes, which observe electromagnetic radiation at millimeter and submillimeter wavelengths. These were used for observing Venus's atmosphere, and for everyone's surprise, phosphine was found in it. So what does this mean for us? Phosphine is a pyramid-shaped molecule with one phosphorus on top and 3 hydrogen atoms in the base, and is the simplest gas with phosphorus in it. Fun fact, the ancient Greeks called the morning star Phosphorus, or the bringer of light, which I found to be a cool coincidence. Phosphine is a special discovery, as it is a biosignature gas. That means just like oxygen, water and methane, it can be connected to life, and in phosphine's case, anaerobic life. That means life that does not require oxygen to survive, like some bacteria. On Earth, such bacteria is the only natural way to form phosphine. But this does not mean we have found alien bacteria on Venus. Phosphine has also been found in the past in the atmospheres of Jupiter and Saturn without any trace of life. But on rocky planets, there are no such high pressure conditions to form phosphine. Still, scientists don't believe that there is no explanation to this other than life. Even though a research paper published in January explains that how phosphine can be useful for discovering life in the universe. Even Carl Sagan, back in the 60s, with Harold Morowitz, wrote about the possibility of life in the clouds of Venus. When it comes to this discovery, it is still unclear how phosphine is present on Venus, and scientists are still figuring it out to explain this without jumping to the conclusion of life. But it would be still fascinating to find life in the solar system somewhere other than Earth, and proving that we aren't really alone in the universe and life can be more common than it seems to be. If you like this video, subscribe and drop a like. I'll be making such videos every week, and thanks for watching. See you in the next video.